In this video, we're going to talk about how matrices can be used to solve systems of equations. So I have an example here. Write the augmented matrix for the following system of equations. Well, what do I mean by augmented matrix? Well, basically, we're going to turn this system of equations into a matrix, and that matrix is going to have is going to be a 3 by 4 matrix. It's going to have 3 rows and 4 columns. So the first row, we'll have 3 minus 1 minus 1, and 11. So notice the 3 came from the coefficient of x, the minus 1 and the minus 1 came from the coefficients of y and z, and the 11 is the number on the right side of the equation. Okay, continuing on, for the second row we would have 1, 2, minus 5, and minus 8. And lastly, in the third row we'd have 4, 5, minus 21, and minus 31. This matrix here is called the augmented matrix for that system of equations. And notice it's a little bit more compact way of writing this. We don't have to write all the x's, y's, and z's, but it really contains the same information that the original system of equations had. Oh, and by the way, if you had not included this last column over here, if you had just had a 3 by 3 matrix that represented the coefficients of x, y, and z, that would be called a coefficient matrix. The reason this is called an augmented matrix is because we're taking this coefficient matrix and augmenting it by this row here, which represents the numbers on the right sides of the equations. Sometimes we put a bar here to represent where the equal sign is. Okay, but this is really a 3 by 4 matrix. Okay, now our goal is to solve this system of equations just using matrices. Basically what we want to do is come up with a new matrix that's equivalent in some sense to that first one, that has the form like this. It has the form where we have ones right here, zeros right here, and some numbers over here. Now it turns out for this system of equations, those numbers would be 4, minus 1, and 2. This was the system of equations that we solved in the last video. But notice if we were to take this augmented matrix and translate it back into a system of equations, this would say 1x plus 0y plus 0z is equal to 4. So in other words, it really just says x is equal to 4. The second row, okay, if we were to turn it into an equation, would say 0x plus 1y plus 0z is equal to negative 1. Or in other words, more simply, we could just say y equals negative 1. And lastly, the last equation is going to say z equals 2. 0x plus 0y plus 1z equals 2. Okay, so, oops, that's supposed to be positive 2. Okay, so how do you transform this matrix up here into a matrix that looks like this? By the way, this matrix down here is said to be in reduced row echelon form, okay, or RREF for short. Okay, it's where you have ones kind of along the diagonal here, zeros everywhere else. This is in reduced row echelon form. So how do we transform a matrix up here into an equivalent matrix that's in reduced row echelon form? Well, we do elementary operations just like we did in the previous video. Sometimes they're called row operations or elementary operations. It really means the same thing. Okay, and so you can interchange two rows of a matrix, for example. You're allowed to multiply a row of a matrix by a non-zero constant. You can replace a row by the sum of itself plus a multiple of another row. So you have those three elementary operations. And by the way, for a system of equations, a computer or a calculator, you could one way to solve the system is you could just enter in this matrix into a calculator or a computer, and a lot of times there's a way that will give you the equivalent matrix that's in reduced row echelon form. You just put in the matrix and then hit a certain button, and out will pop this matrix, and it solves the system. So if you had a really big system of equations, for example like a system of 10 equations and 10 unknowns, definitely be much easier to enter it into a computer than it is to do it by hand, because this process, doing it by hand, takes some time. So for example, let's rewrite this matrix down here, rewrite it down here, and what you can do is begin with your first step. Now remember, when we solved this equation, we weren't using matrices. What we did is we interchanged the first two equations. Well, we'll interchange the first two rows. So what I would put is R1 instead of equation 1. We can put R1, okay, is being interchanged with R2. So you take this matrix and just rewrite it so that we flip the first two equations. Now the third equation, right, the third row is not changing, but these middle two rows are changing. So we're going to have the 1, 2, minus 5, minus 8 be in the top row. The 3, minus 1, minus 1, 11 will be in the middle row. Okay, so that was an elementary operation or a row operation. We can do that. Okay, the next thing that we could do is we could multiply this top row by -3 and add it to the middle row, right? We do -3 times row 1 plus row 2, and that will give us a new row 2. Okay, so again, you can work your way all the way down. We're not going to get a new top row or a new bottom row, but we will get a new middle row. Now we're going to do -3 times the first row plus the second row. So -3 times 1 is -3, plus 3 gives you 0. And that's the whole point. Remember, we want a 0 there. Eventually, we want to get 1s all along the diagonal and 0s everywhere else. Okay, so then you do -3 times 2 plus a -1 is going to give you -7. -3 times -5 is +15, plus -1 is 14. -3 times -8 is 24, plus 11 is 35. Okay, then there's other things that you can do, but basically you want to get a 1 here, then a 0, then a 1, then a 0, 0, 1, and then you work your way backwards and get a 0, 0, 0 here. And these numbers over here will constantly be changing, and hopefully when it's all said and done, you get this matrix that's in reduced row echelon form. Okay, where you can just kind of read off your answers, right? Remember our solution was 4, minus 1, 2. Okay, well, my math lab has a couple of problems. Let me show you one of the problems where it says to perform some of these operations. So it says replace row 2 by row 2 plus -6 times row 1. So basically we're doing row 2 plus -6 times row 1. That's going to give us a new row 2. Okay, so notice the this top row is not changing. We can still write 1, 4, -6, and -7. Okay, also, we're not getting a new third row either. We're going to have -8, 4, 7, and 7. But we are going to get a new row 2, right? We're replacing row 2. So how do we do that? Well, we do -6 times row 1 plus row 2. So -6 times 1 is -6, plus 6 is 0. In fact, that was the whole point of them doing that, is to make this a 0. Okay, -6 times 4 is -24. -24 plus 9 would be -15. And well, let's see, I guess there's two more. -6 times -6 would be +36, plus 5 would be 41. And -6 times -7 would be 42, and 42 plus 5 would be 47. Okay, so you do this, and you would hit enter and check to see if you got it right, and well done. Okay, there's several problems like this. By the way, this whole process is called Gauss-Jordan elimination. Okay, named after two mathematicians, Gauss and Jordan, and it's called Gauss-Jordan elimination. Okay, it's where you begin with basically solve a system using matrices. You begin with the augmented matrix, and you get the final answer here in reduced row echelon form.